In this section, we're going to be covering transformations of functions. So to begin, let's go ahead and just talk about what are transformations. So pretty much a transformation is when we start with an existing graph or an equation, and we modify it with the transformations below, right? So we're going to start with a graph or with an equation again, and you can kind of modify it with these little modifications here, and this is what we call transformations. So make sure you have this table handy, and I'm going to be including it in every slide because it's going to help you a lot in identifying what kinds of transformations happen in a graph. So I'm not going to go into depth right now, but we are going to be going over all of these in the new examples we're going to be covering. So before we go on into actual examples, I want to take some time just to quickly review the six parent functions we've talked about before, right? So we have linear functions, which look like just a straight line. We have quadratics, which look like happy faces or sad faces. They're called parabolas. We have cubics, which look like little snakes. We have the absolute value, which looks like a V. A square root, which just looks like a half of a parabola but sideways, and then we have the cube root, which is like the laying down snake. So again, you don't have to know much about them yet, but I just want to know that you remember what they look like because it's going to be very important in some of the examples we're going to be working on today. So make sure you have this handy as well. Okay, so before we tackle some problems, let's go ahead and just go over the steps on how to work with transformations, right? So step number one, whenever I present to you an equation, first thing you have to do is identify what parent function it belongs to, right? So we've done problems like these and we're going to be doing that today as well. Once you already identify the parent function, you're going to identify all the transformations that have been made to either the graph or the equation because we could apply more than one transformation. Once you identify the transformations, then you could perform them in the following sequence. It's important that you follow this sequence. You always start with horizontal shifts, then we talk about stretching or shrinking, then we talk about reflections, and then vertical shifts. Again, it's okay if this doesn't make sense yet. We're going to do an example and you'll see what I mean. So here we go. Let's go ahead and start with this one. So before we start looking at graphs, we're going to end today's video with graphs. But before we get there, let's go ahead and become experts on equations. So if you notice here, we have an equation, right? It looks scary, I know. But the first thing you should ask yourself, remember, what is the parent function of this one? And if you remember, every time you see a little to the third power anywhere in the problem, you should know that the parent function here is a cubic. And this is what the cubic equation looks like. We have x to the third power. Now, step two, we have to identify the transformations. So before we do that, before we actually identify them, I want to see how many transformations I have. So again, x to the third power used to be the original equation right here. But if you notice, there's extra numbers in there. We have a negative in the front. We have this 2 in the front. We have this negative 4 on the inside of the parentheses, and we have this positive 7 at the very end. Each little thing I circled represents a transformation. All we have to do now is just identify them. So let's go ahead and start with the 4 inside. So when you have a 4 inside a parentheses, you don't have to memorize what the transformation is. This is what the table is here for. All right, so let me go ahead and erase all my doodles here. Again, we're just focusing on this -4. So I come to my table and you're going to look for in here which one looks like that -4. And that's going to tell you what kind of transformation it is. So let me go ahead and erase this again. We have a -4. If I come here, this is the one where the 4 falls into. When you have a number that is negative inside the parentheses. So what does that do? That means that that 4 is a horizontal shift. So that means that the graph is going to move to the right. So if you notice, when you have a number inside the parentheses, that means that it's a horizontal shift. Since it's a minus, I know this makes no sense, right? But every time you have a minus, it's a shift to the right. So that means that my graph is going to move to the right 4 units. All right, so that is one transformation already. I don't think it was that bad. Now let's go on to the next one. So we already did this one. Now, if you notice, the next one in line is this one up in the front. Because when you have a number in the front, it's a shrinking or a stretch. And based on the last line, remember, after we do horizontal shifts, we move on to see if we have vertical stretches or horizontal stretches. So again, we look at the number in the front, and right now ignore the negative because the negative is its own thing. When you have a number in the front, what happens? Remember, come over here and this should tell you. So the number is not inside the parentheses because we already dealt with that one. This one is a number outside or inside the parentheses. This is the one we're looking at. We have a number on the outside of the parentheses. So that means I'm going to follow this one. This one says that I'm going to have either a vertical shrink or a vertical stretch, one of those two. How do I know which one it falls under? Well, I look at the number. If the number is between 0 and 1, that means that it's a fraction such as 1/2 or 3/4, then it would have been a vertical shrink. But since the 2 is greater than 1, it means we're going to have a vertical stretch. Okay, so again, let me go ahead and clear this up. We already did this one. Now we already did the 2. The 2 ended up being a vertical stretch, and we say it by a factor of 2, whatever that number in the front is. So this would have been a 7. It would have been a vertical stretch by a factor of 7, but it was a 2. So hopefully you know what's going on, right? We're starting with an original function, and then we're throwing numbers in there that each represent a transformation. So the 4 meant a horizontal shift, the 2 meant a stretch. Now again, go back to the notes we just took. What's the next transformation we have to tackle? We have to tackle reflections. Remember, they're in order here. So reflections happen when you have a negative, either on the outside or in the inside. So this one, we have a negative. It's outside the parentheses. So I'm going to use this little one right here, right? Because the one on the bottom is when you have a negative on the inside, but we have a negative on the outside. So that means my graph is going to be reflected about the x-axis. So there you go. If you notice, the graph is growing and growing, right? So again, the negative is a reflection about the x-axis. So we've already tackled all of those. The only thing we have missing is the 7. So when you have a number on the outside, it represents a vertical shift. Now, the vertical shift is going to tell you if it goes up or down depending on the sign. Since this is a positive 7, my little table tells me that it's going to be a shift up. So that means my graph is going to be shifted up, of course, 7 units, because that's the number. Okay, so hopefully this is making sense. Again, we're not talking about the graphs. You're actually going to be able to see a visual representation of this towards the end of the video. But for right now, we just want to make sure that you are able to identify what every single little number and symbol does when you manipulate an equation. So again, the parent function was a cube, which if you remember from your notes, looks like this. And then these are all the transformations that happen. Just pretend this little snake is moving to the right 4 units, and then it's vertically stretched, and then it's reflected, and then it's shifted vertically. Okay, so again, that's what's happening. Are you still a little bit iffy? Don't worry. Let's go ahead and try another one. So here we go, right? So they're giving us an equation telling us to identify the transformations. First thing you do, remember, step number 1, you have to identify the parent function. I don't see any powers, so it's not a quadratic, it's not a cubic. But of course, the first thing you guys should see is that there is a square root. So that means that the parent function is going to be a square root. And again, if you were to graph this, if you look at the parent functions, the graph of this looks like that. And we're going to be manipulating it, so it's going to move around depending on the things that we have. So again, this is the original equation of a of a square root. Now, what's the difference between this and that? Let's see. We have a +2 on the inside, so that's going to be one transformation. We have a fraction on the outside, so that's another transformation. And then we have a -1 at the very end. So that's another transformation. So we should have a total of 3 transformations on this one. Let's go ahead and start identifying them. And again, we go in order. So let's go in order of the table. So let's see, do we have horizontal shifts? Horizontal shifts is when you have a number on the inside of the parentheses. Of course, in this problem, we don't have parentheses, but since this is our parent function, whatever is inside here is kind of like if it's inside of a parenthesis. So yes, we have a horizontal shift. Now, if that's a +2, so is it going to be to the left or to the right? Of course, you come and just look at the table, right? When you have a positive number, it's a shift to the left. So that's my first transformation. The +2 means I'm going to have a horizontal shift to the left 2 units. All right, let's keep on going on the table. Do we have a stretch or shrink? This happens when you have a number on the front of the equation or inside the parentheses, which in this case means inside the square root. So there's no number inside the square root here in front of the x, but we do have a number in the front of the square root. So that means I'm going to have or I'm going to fall under this one, right? I have a number in the front, and now I'm either going to have a vertical stretch or a vertical shrink. How do you know? Well, you compare that number and see which one of these does it fall under. So is 1/3 between 0 or 1, or is 1/3 greater than 1? If you're not sure, you could just divide 1 over 3 is 0.333. So that means it falls between 0 and 1. So that means I'm going to be having a vertical shrinking. Okay, again, I will explain what all of those things mean towards the end when we have graphs. But here we go. Right now they're just asking us to identify. So after the horizontal shift, now I have a vertical shrink by a factor of 1 over 3. Okay, so pretty much vertical shrinks, it just means that the graph is being shrinked. Okay, so we are of course not done. We already looked at the 2, we looked at the 1 over 3. Let's go ahead and look at the next one. Reflections. Do we have reflections? Reflections happen when you have either a negative in the front or a negative inside the parentheses in front of the x. So here again, there's no negative in front of the x. And is there a negative up here in the front? No. So in this case, we have no reflections to worry about. All right, let's keep on going on the table. On the table, the last thing we have to look is, do we have a vertical shift? Vertical shifts happen when you have numbers at the end of the equation. So outside the parentheses, in our case, outside of the root. Do we have a number on the outside? Yes, we do. We have a -1. So I come to the table. When I have a negative number, like here, I have a vertical shift down. So that is actually my last transformation for this one. Since it's a -1, I have a vertical shift down 1 unit. Okay, so again, that's the steps that we follow. We first identify the parent function and then tackle each transformation individually. You're always supposed to have this little table handy because it tells you what each transformation does. All right, let's go ahead and try this one. On this one, I don't give you a parent function. I just want you to be able to identify and know how to read the table. So if this is my original function, f of x, what happens if I do f of x with a -2 at the end? Again, you should go and be able to tell me, okay, it's not going to be these because this is when the number is inside the parentheses, so these are out. These two are when you have a number in the front or inside the parentheses, which we don't. Since we don't have negatives, it's not one of those. And then it would be this one right here, right? Because the number is outside the parentheses and it's a negative. So that means that I'm going to have a vertical shift down. So that's pretty much what we wanted to do here, right? So we have a vertical shift 2 units down. Okay, let's go ahead and try the next one. What happens if I grab an f of x and I convert it to f of 7x? So look at that. We have a number inside the parentheses in front of the x. So let me go down my table. Which one's the one? It would be this one, right? This is when I have a number. Remember, C represents a number. So this is when I have a number inside the parentheses. So I have a horizontal shrink or a horizontal stretch. Let's see. 7 is greater than 1. So that means I'm going to have a horizontal shrink. So for that one, I have a horizontal shrinking by 7 or by a factor of 7. So when we use the word by a factor is when we have one of these, vertical shrinking, stretching, or horizontal shrinking and stretching. All right, let's try a couple more. So here we have f of x equals x squared. So the parent function here is a quadratic, right? And we're only doing one transformation here. So what do you notice? The only difference from here to here is the plus 14. And where is the plus 14? It's inside the parentheses. So I come over here. Where do we have a number that's inside the parentheses? It's one of these two. Since it's a positive 14, I'm going to follow this one, right? So it's going to be a horizontal shift to the left 14 units. Okay, so again, please, hopefully you're not getting super confused. Remember, the table is the one that tells you what to do. All right, let's try one more on this slide. Same scenario, we have a quadratic as a parent function. What happens here? So in the last problem, the 14 was inside the parentheses. In this problem, the 14, there's no parentheses, so the 14 is outside the equation. So again, we come over here, it's not going to be these because on these, the number's inside the parentheses. On this one, it's outside in the front. Then this one's inside, so these are still out. This one just deals with negatives, with negative signs. So it's one of these two. And the answer is the one that has the positive. So that means I have a vertical shift up. So the transformation on this one is a vertical shift 14 units up. All right, we have a couple more examples. Let's keep on going. Parent function is the square root of x. Now what happens if I add a 14 in the front of the square root? So again, you should know that it's this one, right? We have a 14 in the front of the equation. Now again, to know if it's a shrink or a stretch, you look at the 14. Is the 14 between 0 and 1, or is the 14 greater than 1? So since 14 is greater than 1, I have a vertical stretch. So I have a vertical stretch by a factor of 14. Now the difference between that one and the next one, again, our parent function is still a square root, but now on this one I have a 14 inside the square root. So again, it's not one of these two because this one does have numbers in the inside the square root or inside the parentheses, but they're next to the x, so it's not this one. We're looking for one where the 14 or the number's in front of the x. So it's right here, right? So this one, the number is in front of the equation, which is not the case because if not, the 14 would be out here. But it's not. So it's not that one. It's this one, right? The c, which represents the 14, is inside the parentheses or inside the square root in our case. Remember, the square root acts as a parentheses, and it's in the front. So we have identified our transformation. Now, since it's this one, we just have to identify, is it a shrink or a stretch? 14 is greater than 1. So I'm going to have a horizontal shrink by a factor of 1 over 14. I know what you're thinking, right? So the reason I put these two together is because look at this. In one of them, I say 14, and the other one, I say 1 over 14. So the only time you're going to change a number into a fraction, and please make a note of this on your notes, is when you have a horizontal shrinking. So when you have a horizontal shrinking here, you convert this into the reciprocal of whatever number is here, right? So if this is a 14, then all you have to do is just put 1 over 14. If this would have been a 75, it would be 1 over 75. So when we're shrinking horizontally, if you notice, we do by a factor of, we put it as a fraction. But in the last example, where we're talking about vertical stretches, there's no need to make it into a fraction. It would just be whatever number was there. Okay, so again, make a little note of that. If you ever encounter a question similar to this one, just come back to your notes and you should be able to find it here. When you have a horizontal shrink, then we do the fraction form, which is 1 over 14. Because it makes sense, since we're shrinking, if we would have done a factor of 14, the graph would have gotten bigger. But since it's shrink, we have to do 1 over 14, so it becomes smaller. Okay, let's change things up a bit. So up to now, all of the problems, I give you the equation and you identify the transformations. Now I'm going to flip it around. So they're giving us the parent function, which is a quadratic, and now they're giving us a transformation. So we have to manipulate the equation. So let's go ahead and read the instructions. Write the new equation of f of x, so this is the original. We have to convert it or transform it in this way. We're going to have to shift it 6 units up and 3 units to the left. So we're going to have to add 2 transformations to this equation. Okay, it's very possible we can do this. So let's go ahead and do the first one. So this is my original equation. Always start with the original, right? So the original one is x squared. Now there's 2 transformations. So let's go ahead and start with the first one. So remember, we always start with horizontal shifts. They told us horizontal is left to right. So they told us we were supposed to move the graph 3 units to the left. So we come over here, and when we move something to the left, I put that number inside the parentheses as a positive. So if you notice, the x squared is still here, but in parentheses, I put a positive 3. Again, because they told us they wanted 3 units to the left, and we look at the table, when we move to the left, we have a positive number. Okay, so hopefully that made sense. So you notice now we're going backwards, right? They give us the transformations and we're the ones manipulating the equation. So we already have this one out of the way. Now the only one we have to deal with now is 6 units up. So I'm going to skip this because we're not shrinking or stretching. We don't have any reflections. Now we go to vertical shifts. Vertical shifts is when we move the graph either up or down. So let's go ahead and see. We're going to have to add the number at the very end of the equation. So the 6 is going to go at the very outside the parentheses on the very end. Now, since it's 6 units up, that means that, let's go look at the table. When I go up, the number has to be positive. So that means I'm going to get this equation. And if you notice, all I did was add a 6 at the very end. And there you go. That's actually your answer, right? So look at what we did. They gave us the original, and then we manipulated it, right? So we added a +3 and a +6 at the end because we had two transformations. We had a shift 6 units up, and we had another shift 3 units to the left. So again, you're not on your own. You have that table there to help you out. Okay, let's try another similar one. Again, make sure you always read the problem because sometimes the original equation is already a little bit manipulated. So if you look at this one, this is the original one. So that's what we're going to start with. So let me just go ahead and do that first. That's my original equation. We're going to have to modify it with whatever they're telling us to do here. So write the new equation of f of x if it is shifted 2 units down and 6 units to the right. So we have two transformations. So let's see, let's start with the table and see which one we deal with first. So let's see, do we have a horizontal shift? Again, horizontal means left to right. So yes, we do. We have 6 units to the right. So let me look at the table. In order to display that on my equation, to the right means I'm going to put the number inside the parentheses, and it's going to be negative. So since it's 6 units to the right, that 6 is going to go inside the parentheses, but we don't have parentheses, we have a root. So that means that the 6 is going to be inside the root. And since it's to the right, the table says that it has to be negative. So what I'm going to do is just put the 6 inside and negative. Okay, if you notice the 3, I didn't even touch it. Since it's part of the original equation, I just leave it there. The only thing we did was add the 6. Okay, nowhere in here did they want us to shrink or stretch, so I'm going to skip this. Again, nowhere in here did they say anything about reflections. And did they say something about vertical shift? Yes, they did. Because remember, vertical means up and down. So I have a shift of 2 units down. So what does that mean? I'm going to have 2, let's see the table. The table says that when I go down, I'm going to have to add the number outside at the very end. So 2 units down, that 2 is going to come out here at the very end, and it's going to be a minus. So my final answer is that little mess right there. So again, this was the original equation. So the 3 and the x are still there. But since they applied two transformations, I had to put them in the equation. And again, you don't have to memorize where things go. That's what the table is for. All right, here comes the good part. Now we're going to start looking at graphs so you can actually visually see what the transformations do. So look at this one. Here, they don't give us any equation. We're going to have to come up with it on our own. So give the equation of the graph below. So first thing I want you to do is just stare at the graph. What does that graph look like? So you do have to go back to your notes on the parent functions, which we did earlier on the video. What graph looks like a V, like this one? So the answer is an absolute value, right? So that means right off the bat, I know that this was the parent function. Okay, of course, this doesn't represent this because if you look on your notes, the parent function starts right here, right? It starts right at the origin, which is not the one that they gave us. So we're going to have to manipulate it, but we can do this. It's super simple. So if this is a parent function, how do I manipulate it so it ends up being over here? So let's see. Let's go ahead and start with the table. Do I have to move it horizontally? Do I have to move it to the left or to the right? Yes, right? The function, the graph that they gave us is 1, 2, 3, 4 units to the left of the original one. So that means that if I moved it to the left, right? Remember, this red one represents the original one from the notes, and this black one is the one that they want us to end up with. So I'm going to have to move the original one 4 units to the left. So that means I'm going to have to add a +4 inside the parentheses. Again, I don't have to add parentheses because the absolute value kind of represents parentheses. So that's the first thing I'm going to do. I'm going to add a +4, which according to the table represents a horizontal shift to the left 4 units. So pretend that this V moves 4 units to the left. So now it's here. Okay, we're still not done though because it has to end up over here. So what do I do now? So, okay, let's see. Do I have to shrink it or stretch it? No need to, right? It doesn't look weird or anything. Do I have to reflect it? Do I have to like twist it up and down? Not really. Do I have to move it up or down? Yes, right? So that V is almost done. I just have to move it 1, 2, 3 units down. So according to my table, in order to move something down, I'm going to have to put a negative number outside the parentheses. In our case, outside the absolute value sign. So I'm going to have to come and put a negative number on the outside. So how many times did I have to move it down? 3. So that means I'm going to put a -3 on the bottom. Okay, so again, I know this might be a little confusing, so let me go ahead and just walk you through it again. So as soon as you see this graph, you should be like, okay, I know this is an absolute value, but according to my notes, the absolute value originally starts here. How do I transform it so it becomes this one? So if you notice, we had to move it 1, 2, 3, 4 units to the left. That's why we have this +4 here. And again, I know to the left doesn't represent a positive, but according to our table, that's what we do. When we have moving something to the left, it has to be a positive number. And then from there, I move it 1, 2, 3 units down. So that's how I got this -3. And again, look at the table. When we shift something down, we put a minus. And that is how you manipulate the original parent function to become the one that we were given. So I don't think it was that bad, right? But if you're still a little stuck, let's go ahead and try one more. So let's try this one. Just like the last one, what's the parent function of this one? Yes, right? So the parent function is still the absolute value, and I'm going to go ahead and draw the original one. The original parent function starts here. What do I do to the original one so it ends up being here? So let's see. And remember, we always start in order. Do we have to move it horizontally? Yes, right? We're going to have to move this little point 1, 2, just 2 units to the right. And remember, when we're moving something to the right, we have to represent it with a minus sign. So since I moved it 2 to the right, the -2 has to be inside the parentheses or inside the absolute value. So I put a -2. I cannot end it there because if that's the only transformation I do, that means the graph would be here, which is not, right? It's down here. So I still have to not stretch it or shrink it, not reflect it. I still have to move it vertically. So I'm going to have to move it 1, 2, 3 units down. So according to the graph, I'm going to have to put a -3 at the end, outside the parentheses or outside the absolute value sign. So I just come here and I put a -3 and voila, that would be it for this one, right? We only needed 2 transformations in order to move the original parent function to where they wanted it to be. All right, let's try the last one here. This one, what does this one look like? What's the parent function? So this one cannot be a linear, that's not a straight line. This one cannot be an absolute value because that does not look like a V. The closest thing to this one is a square root. So if you look at your notes, a square root looks like this, right? Just one, like half a parabola sitting down. Okay, now how in the world do I convert this red line to this blue line that they want? So let's see, do I have to move it horizontally? Is there any way I could move this left or right to make it look like this? There is no way this is ever going to look like this just by moving it left and right. So I don't need any horizontal shifts. Okay, can I stretch or shrink this red line to make it look like this? Okay, what shrinks and stretches do is that if you were to like stretch it, it would get probably like this. If you were to shrink it, it will get kind of skinnier. So whatever you do, any shrink or stretch, this is never going to look like that. So let me go ahead and erase this real quick. So we had already said no to horizontal shifts. Now no to stretches. Now let's say a reflection. Can I do something to this so that it looks like this? Will reflection do that? Let's see. So if I were to reflect this about the x-axis, this is your x-axis. So pretend you have this written down in your paper, which hopefully you should. If you were to fold your paper along this line, will the red line end up being the blue line? The answer to that is yes. So the actual reflection here would be the only transformation we would need. Now, let me just go ahead and show you real quick what a reflection on the y-axis would do. So the reflection about the x-axis, you fold your paper along the x-axis. That means that this line would end up being here, which is what we wanted. But just for practice, let me show you what would happen. If this would be the original one, and it would be a reflection about the y-axis, which is the y-axis here, you would fold your paper here, and this red line would end up being over here. Okay, again, this is not what we want, but I just wanted you to see what the reflection about the y-axis does. But again, this was the original one, and all we have to do is reflect it across the x-axis. So let me go ahead and see what does that do. If we want to reflect about the x-axis, I have to add a negative sign, but on the outside of the function. So this is my original function. All I'm going to do is add a negative in the front, and we're done. That was easier than the last one, right? So again, this is what happened. They gave us a graph, which was this right here. We had to sit there and see, okay, what parent function looks like it. And of course, we agreed it was the square root function. But the square root function looks like this. So how do we change this into that? Well, we just had to reflect it. And I come and look at my table. And in order to reflect across the x-axis, all I have to do is add a little negative in the front. Okay, so like I said throughout the whole video, just make sure you have this handy and keep on practicing. Of course, if you do your homework and you see there's something that's not clicking or that it's giving you trouble, remember you can always come to me and I can give you more examples and I can walk you through it.